So in this video, I want to solve a fourth order linear homogeneous ordinary differential equation with constant coefficients. So many adjectives. But here we have a fourth derivative of y minus 81y equals 0. And so we know what to do. We know that we need to look at the equation r to the fourth minus 81 equals 0. And then depending on what happens with our values of r, that tells us what our solutions are going to be. So this means that we're going to look at that equation. And of course, this equation is going to turn out to have four solutions over the complex numbers. The complex numbers are special in that if you were to have any polynomial of degree n, you're going to get n solutions. Maybe some of them will be repeated. So maybe you get the same solution n times, but you're always going to have n solutions. So the mathematical way to say this is that the sum of the multiplicities of the solutions will be n. So you'll always have n solutions up to multiplicity. So in our case, if we have r to the 4 minus 81, we're expecting 4 solutions. So what we can do is we can factor this, because this is a difference of 2 squares. This factors as r squared minus 9 times r squared plus 9 equals 0. And of course, r squared minus 9 equals 0 implies that r is plus or minus 3. So no, nothing mysterious there. But r squared plus 9 equals 0 tells you that r squared is going to be negative 9, which tells you that r is going to be plus or minus the square root of negative 9. And if you have a negative inside the square root, what you can do is you can bring the negative outside the square root and make it an I. So this means that we're going to have solutions plus or minus 3i. And so now we have 4 solutions, 3 and negative 3. And then remember, complex solutions come in pairs. So in this case, we have plus or minus 3i. So if we think about, so let me write that. We have 3, negative 3, and then plus or minus 3i. Those come in pairs. So I'm going to write them together. And that means that our general solution y to the differential equation is going to be c1 e to the 3x plus c2 e to the negative 3x. And that handles the first 2 solutions. And then when we have complex solutions, you're going to have e to the 0x, and it's 0 because this is these are purely imaginary numbers. So they're complex numbers where the real part is 0. And so this would be e to the 0x times, but e to the 0x is 1, so you don't have to write it, but times c3 cosine of 3x plus c4 sine of 3x. Okay, and so that's going to be our general solution there. So that's a 4th degree ODE with constant coefficients.